Students, we have been given this beautiful question. Let me state the question. If alpha is equal to integral 0 to 1 e raised to the power of 9x positive 3 times tan inverse of x times 12 positive 9x squared divided by 1 positive x squared times dx. So this is the quantity of this fashion, where tan inverse of x takes only principal values. Then we are expected to find the value of ln modulus 1 positive alpha negative 3 pi over 4. So foremost, what I wish to do is I would like to consider the given question. Consider integral 0 to 1 e raised to the power of 9x positive 3 times tan inverse of x times 12 positive 9x squared divided by 1 positive x squared times dx. Then what I will do is I will use the technique of substitution. So I'll start off like this. Let 9x positive 3 times tan inverse of x be equal to t. I differentiate this, I get 9 positive 3 times differential of tan inverse of x is going to be 1 over 1 positive x squared times dx. This is equal to dt. I take the LCM as 1 positive x squared. I would get 9 positive 9 times x squared positive 3 times dx is equal to dt. This is equal to 9 added with 3 would give me 12 positive 9 times x squared divided by 1 positive x squared times dx. So this is what I would get, and that would be equal to dt. So now we can clearly see that 12 positive 9x squared times dx divided by 1 positive x squared is already available here, and I can rewrite this as e raised to the power of 9x positive 3 times tan inverse of x is t, and this entire quantity is dt. Now the limit comes into play. Now what are we going to do? So I would be changing the limits using the method that I've just mentioned. So for that, let me use this space here. So I will want to get the equivalent limits for t. So when x is equal to 0, my t is going to be 9 times of 0 positive 3 times of tan inverse of 0. So this is going to be t is equal to 0, right? When x is equal to 0, clearly you can see that t is equal to 0. Now the next step comes when x is equal to 1, what happens to t? Let me write that down. T is equal to 9 times of 1 positive 3 times of tan inverse of 1. Now this is equal to 9 positive 3 times tan inverse of 1 is pi over 4. So this is what we get. 9 positive 3 pi over 4. So the limits are 0 to 9 positive 3 pi over 4. Now if I were to integrate this, this is going to give me e raised to the power of t, with the limits being 0 to 9 positive 3 pi over 4. So I substitute the upper limit, I would get e raised to the power of 9 positive 3 pi over 4 negative e raised to the power of 0, which is nothing but e raised to the power of 9 positive 3 pi over 4 negative 1, because e raised to the power of 0 is 1. So this is what we have got. And what is this exactly? If alpha, so this quantity is nothing but alpha, right? So we have got alpha is equal to this. So let me move this 1 to the left side. So this would mean I get alpha positive 1 is equal to e raised to the power of 9 positive 3 pi over 4. Now let me take ln on both sides. So this is going to be ln of alpha positive 1 is equal to ln of e raised to the power of 9 positive 3 pi over 4. Now we know that ln of e, because e and ln, they get neutralized. So this would give me 9 positive 3 pi over 4. Okay, so this is for the ln. But we are expected to find the ln of 1 positive alpha negative 3 pi. So therefore, I can state here ln of, you can either write it as alpha positive 1 or 1 positive alpha is equal to, in fact I should have placed this negative. So let me just place this negative sign. So it's going to be negative 3 pi over 4 is equal to, for ln of alpha positive 1 I can substitute 9 positive 3 pi over 4, but there is a negative 3 pi over 4, so substitute. So what do you see here? So clearly 3 pi over 4, 3 pi over 4 can be cancelled, giving me equal to 9. So this is the value, and we have achieved it in a beautiful fashion. So that is the completion for this question, students. We will move on to the next question.